if I were to hand you these two flasks filled with gases, what could you tell me about these two gases? And just by looking at these, the only thing we could tell that's similar about them is that they are both colorless. They're clear, so you can't see anything. But you wouldn't be able to tell me what any differences are. You wouldn't even be able to tell me that these are two different things. But if I told you that they are two different things, then because of our knowledge of chemistry, we could actually come up with some differences for these. So some similarities are that they are both colorless gases, but some differences is that the oxygen is a pure substance and an element, while air is what's called a homogeneous mixture of multiple different substances. And so these types of classifications is what we're going to talk about in this video. So when we have matter, which is what everything is made out of, it's stuff that has mass and occupies space, we can classify this based on whether it is a pure substance or a mixture, and then we can talk about differences in types of pure substances and mixtures. So the first one we'll talk about are pure substances, and so we can classify these as either elements or compounds, where an element is a pure substance that is composed of just one type of material. That would be anything on the periodic table. So for instance, things like silver or copper or chlorine or mercury, and then compounds consist of two or more elements that are chemically combined, and they're always in the same proportion, meaning that, for instance, if you have something like water, then it always has one oxygen for every two hydrogens. So if you have a container of pure water, you would know that there are twice as many hydrogens in there than there are oxygen. It's always in that same proportion and that same ratio. And like I said, these are always chemically combined together. So we have a bond between the hydrogens and the oxygen here. And so that means that they are composed into a single molecule. Other examples of this would be something like carbon dioxide or sodium chloride. So these are pure substances, but they are compounds. So that means they are made of more than one type of element. So then we also can have mixtures, and the way we can classify these are between homogeneous mixtures and heterogeneous mixtures. By the way, I've heard it called homogeneous and homogeneous. I tend to pronounce it as homogeneous. I think either one is fine, so homogeneous mixtures and heterogeneous mixtures. So again, a mixture is when we have two or more substances that are mixed together. So homogeneous mixtures have a uniform composition throughout. So that means if you look at something like salt water, you can't pick out the individual particles of salt. So the whole thing just looks like it's made of one sort of uniform thing. And another example of this would be air. So air is made out of mostly nitrogen and then oxygen and then a little bit of other things like argon and carbon dioxide and other things like that. But if you just look at air, it just looks like it's made out of one thing. You can't sort of differentiate between all of the different components that it's made out of. Whereas something like a heterogeneous mixture has components that you can sort of tell the difference between, but also that you could physically separate from each other. So for instance, oil and water, you can tell the difference. You can see that there's parts of this that are oil, parts of it that are water, and you could do some sort of filtration or separation that you could use to actually separate those things from each other. So trail mix is another one. We see that there's a bunch of different things mixed together, or US pennies after 1982 when they started using zinc on the inside and just coating it in copper. So we have two different things, the zinc and the copper, and so that makes it a heterogeneous mixture of solids there. And so when we talk about matter, we also have to talk about states of matter and properties of matter. So the states of matter are probably the things that you are familiar with, so things like solids, liquids, and gases. There are probably some of those of you who know that there are more states of matter than that, so things like plasmas, but for a class like this, we're going to just focus on the solids, liquids, and gases. So solids are things like the silver, copper, and sodium chloride. So at room temperature here on Earth, those things are solids. Liquids, so things like oil and water are both liquids at room temperature here on Earth. Same with water, salt water, or mercury. then air and carbon dioxide and chlorine are all gases at room temperature here on Earth. And so we can think of some characteristics of these different states of matter that we can actually use to differentiate them. So for instance, the shape of it, solids have a definite shape, where liquids will actually change shape to fit the container, as will a gas. So this is how we could tell a solid from a liquid and a gas. But then we can also look at the volume of these, where solids and liquids both have a definite volume, but gas will actually expand to fill the container. So if you put a small amount of gas into a larger container, it will expand to fill that container, where the solid or the liquid would just stay on the bottom of that container, would not expand to fill it. We can also think about this at the molecular level. So the solid has fixed and very close particles, where the liquid, they're close, but they're also random. So they're sort of moving past each other, where with solids, they're usually kind of stationary and in place. Then gases, they're random and far apart from each other. And then the interaction between them, so like I said, solids, they're very strong. They're usually strong enough that they are sort of held in a stationary place, where liquids, they're strong enough that they don't sort of separate from each other, but they are able to slide past each other. And so that's why they can sort of move and change shape to fit the container that it's in, where a gas has almost no interaction between particles. And actually, later on in these videos, I will talk about things like the ideal gas law, where we essentially assume that there is no interaction between particles and a gas. And like I said, we have the movement of particles, where for solids it's very slow. Oftentimes we think of it as stationary, at least relative to each other. They do have vibrations and things like that, but they are often sort of held stationary relative to each other. Where liquid, we do have movement. They can sort of slide past each other, but they do not separate from each other. Where gas is very fast. In fact, they're fast enough that they can sort of break apart from each other and move independently of each other. And so just some examples. So solid, things like ice or salt or iron. Liquid, as we saw, we had water, oil, vinegar. Gas would be things like steam and helium and air. But when we're doing an observation in the lab, if we don't have the sophisticated sort of instruments that some labs might have, we're usually just interested in these two right here. So these are two things that we can use to differentiate between these. And so for instance, if we have something that has a definite shape, we know it's going to be a solid. If we have something that will fit the shape of its container, then we want to look at whether it has a definite volume or whether it will expand to fill the container. So if it expands to fill the container, then we would know it's a gas. If it does not do that, then we have a liquid. And so this is just kind of a pictorial representation of what we've been talking about, where the solids, the particles are all sort of held in this regular, oftentimes repeating, especially if it's a crystal structure, where these things are not moving relative to each other, whereas the liquid, we have all these particles sort of sliding past each other. Then the gas, they're all very separated from each other, and they're sort of moving independently of each other, oftentimes not interacting to any great extent. And of course, we can move between these different states of matter, and we have names for what these movements between the states of matter are called. A lot of these you will probably be familiar with. So for instance, if we have a liquid become a solid, that's called freezing. And if we have a solid become a liquid, that's called melting. If we have a liquid becoming a gas, we call that boiling. And when we have a gas becoming a liquid, we call that condensation. Then two that you might not be as familiar with, so a gas becoming a solid is called deposition. So you can think of it as just sort of a solid depositing onto something. And if we have a solid becoming a gas, that's called the sublimation. So if you've ever seen dry ice, the reason it's dry is because it doesn't go through the liquid phase. It goes right from solid to gas, and that's why you see that steam just coming off of this solid. And so matter can also be described by its physical and chemical properties. So this is sort of a step up in generality from what we were just talking about, because what we were just talking about were called physical properties of matter. But we can think of this in terms of physical and chemical properties of matter, where the physical properties describe characteristics of the matter, so things like color and odor, and then the specific temperature at which something melts or boils. the viscosity, the density, things like that, where a chemical property describes the ability of a substance to change into another substance. So, for instance, gasoline can burn. So gasoline is made out of hydrocarbons. It can burn and become water and carbon dioxide. Iron can rust, so that means we can have pure iron become iron oxide, and we can have silver tarnishing. So those are chemical properties that these things are able to do that. But then we can also think of these as the actual changes. So if we think of the property as kind of the potential to do those things, then we can think of the actual changes, so physical changes and chemical changes, as the actual action of doing those things. So for instance, the physical change of matter occurs when the matter changes from one state to another. So if we see something in the process of melting, it's undergoing a physical change. Same with boiling or sublimation. Where a chemical change is when we actually have a chemical reaction occurring. And so the chemical property, remember, was sort of the ability or potential to undergo that chemical change, where the chemical change is when it's actually occurring. And so for instance, if we look at something like this, and I encourage you to pause the video and to try this on your own before listening to me go through it. But you might be given questions like this, and you want to say whether these are a physical property, chemical property, physical change, or a chemical change. So we have that sulfur is yellow. We have nitrogen, hydrogen reacting to produce ammonia, and at 100 degrees Celsius, liquid water becomes water vapor, and then number 4, oxygen can burn. So I will let you go through these on your own. And so the answer to these is that the first one is a physical property. So that sulfur is yellow is just a property of it. We're not talking about actually going through any kind of a change, and it's talking about a physical property of it. So this is not a chemical property. Obviously, if you get further into chemistry, you'll know that the color is because of chemical aspects of it, but at this point, we'll just say that the color of it is a physical property of it. Then nitrogen and hydrogen reacting to produce ammonia, that's a chemical change. So, and I specifically wrote this in a way that it's actually sort of talking about the action. So I use the word reacting here rather than saying something like can react. So using the word reacting is saying that it's undergoing the chemical change here. Then the third one, at 100 degrees Celsius, liquid water becomes water vapor. So I call this a physical change, and again, I'm using this word right here, becomes, so that's sort of a verb word here. We're saying that this is actually happening. Whereas number 4, I'm using the word can here. And so that means that we're indicating some potential to do something. So that oxygen can burn is a chemical property. And so that's the way that I word these things when I talk about whether something is a property or a change. So here are a couple more practice problems. Again, I encourage you to pause the video and think about these yourselves. So the following describes which physical state of matter. And so we want to predict what physical state of matter this is describing. So it has a definite volume, but not a definite shape, and it takes the shape of its container. Then number 2, silver tarnishing would be an example of what type of change, physical or chemical. And I will let you work on these on your own. And so for the first one, we have that it has a definite volume, which means that we can rule out that it's a gas, but not a definite shape. And so that means we can rule out that it's a solid. And so even just by those first two, we know that this is a liquid. But then we have this third thing here that just says it takes the shape of its container, which further indicates that it is not a solid. And so this would be a liquid right here. Then silver tarnishing, this is already an example we used. This is a chemical change right here. And that's because the silver is actually changing the chemical makeup of it. It's going from pure silver to silver, probably oxide or something like that. And so finally, we have these last questions here. So again, I encourage you to pause and go through these on your own. But the first one is to classify each as either a pure substance or a mixture. So remember, we're not talking about whether it's homogeneous or heterogeneous. We're not talking about whether it's an element or a compound, just as a pure substance or a mixture. And number 4, we want to classify the following as either heterogeneous or homogeneous mixtures. So we're saying that all of them are mixtures, and we just want to say whether they are heterogeneous or homogeneous. So I'll let you work on that. And so for the first one, we have vinegar. And vinegar, if we just have the vinegar, we know this is a compound and this is a pure substance, at least if we're talking about the acetic acid. If you actually looked at the vinegar that you might have in your cupboard, that would have other things than the acetic acid, so it might be better to actually call this acetic acid. But using this chemical formula here, we're trying to indicate that we are just talking about the acetic acid. But if it was vinegar, then we would actually call that a mixture, and that would actually be a homogeneous mixture. Then aluminum, this would actually be a pure substance here, and in fact that would be an element. Then vegetable soup, this would be a mixture. We have a bunch of different types of things in there. They're not just all one compound. It's made out of tons of different types of compounds, and so that is a mixture. Then for the last one here, we want to classify these as either heterogeneous or homogeneous. So seawater would be homogeneous if we just think about the salt in the water. Obviously, if we start adding a lot of the other things, the microorganisms and stuff like that, then it would probably be heterogeneous. But if we're just thinking about it as the salt in the water, it's homogeneous. Air, as we already talked about before, is homogeneous. And then orange juice with pulp would be heterogeneous, and that's because you could actually physically separate the pulp from the orange juice. Pepperoni and cheese pizza, that's made out of a bunch of different things that can be physically separated, so that'd be heterogeneous. And a glass of soda with ice in it, again, we can separate those by physical means, and so that means it is heterogeneous. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.